Algebra I 12.7c, word problems of joint variation. All right, so for the last 6 or 7 videos, I've had to repeat myself here. Before you watch this video, you have to watch 12.5a, 12.5b, 12.6a, and 12.7a on direct, inverse, and joint variation. There's a couple in there that you don't have to watch where we talked about word problems, but you have to at least watch these basic ones that start with an A, all right? You're going to get confused, and it's because you missed out. You missed what we were talking about, okay? So you can just go to the description of this video, click on them, and watch them real quick. So remember, an equation in the form z equals k xy expresses joint variation. The k is not 0, and it's a constant. We have 3 or more related quantities. We have 1, 2, 3. The more quantities that are being related means the more variables in the equation. So if there's 4 or 5 quantities, we just add more variables back here. They're directly related, aren't they? The more quantities, the more variables. So if there's 3 quantities, 1, 2, 3, and k, we can do it like this. And this x and y, they're jointly related to that z together. What they do together is going to be related to that z. It's going to affect that z. If we have 4 quantities in k, then we'll have 1, 2, 3, 4 variables, and that k constant. And x, y, and z are jointly related. Whatever happens with them is going to affect this w, okay? So the volume of a pyramid varies jointly as the height of the pyramid and the area of its base. And the volume of a pyramid with a height 12 centimeters and a base 5 centimeters squared is 20 centimeters cubed. So if this base here is 5 centimeters square, see, that's the base, then the volume is going to be 20 centimeters cubed when the height is 12 centimeters. See that? That's a little pyramid compared to the Great Pyramid in Egypt. So we could find the volume of the Great Pyramid in Egypt, who has a height of 147 meters and has a base area of 52,900 meters square. So if we're doing apples to apples, we've got a base that's square, just like this one. We've got a height in metric, see? So our answer is going to be cubed, isn't it? So we're going to let V equal volume, B equal base, H equal height, and we're going to use these values to find K and then plug them in to find the Great Pyramid, okay? So we're going to use the equation V equals K times B times H. The volume equals the constant times the base times the height. I'm going to substitute in those first set of values to find the value of K. So that means we have 20 equals K times 5 times 12. See? 20 equals K, whatever that is, times 5 times 12. 5 times 12 is 60, and when we want to isolate K, we can divide both sides of the equation by the 60. That turns into a 1, doesn't it? Now we have 20 over 60, which is 1/3. We can use 1/3 for K. Plug it in to find the Great Pyramid. We plug it in, and the values that it had was 147 meters high and 52,900 meters base. So we plug those in. You're going to need a calculator, unless I'll be really proud of you if you do this the old-fashioned multiplication on paper. We come up with 7,776,300. We have to multiply that by 1/3, which is the same thing as dividing it by 3, isn't it? I'm going to divide this by 3, and we get 2,592,100, and it's meters cubed. That's the volume of the Great Pyramid in Egypt. Now, that centimeter square and centimeter cubed are not considered at all, because the numbers that 12, 5, and 20 are jointly related. See? There's a joint variation there. And we just flip it onto this set of values, okay? So that's why we did the math without any centimeters or meters in it, okay? They were jointly related. Okay? So here's a real quick synopsis and review for a direct variation. Your appetite is going to vary up or down, plus or minus, as the elapsed time from your last meal. So the more hours from your last meal, the more hungry you're going to be. The less hours, the less hungry. That's direct variation. Inverse variation is when it flips opposite. The time it takes to rake leaves in a yard is going to vary up or down, plus or minus, as the amount of people raking. The more people, the less time. See how it flipped opposite? This was more and more. Now, the more people that are raking, the less time it's going to take. And the less people that are raking, the more time it's going to take. See how it's inverse? It flipped, didn't it? Joint variation is like what we just did when two values affect a third one, and the distance that a car goes is going to be plus or minus the rate of speed and the time driving. So it's going to go up or down depending on how fast you're going and how long you're in the car. The more miles that you've covered means the more speed and the more time that you were in the car. The less miles you cover means the less amount of speed you were going and the less amount of time you were in the car. All right? That's joint variation. And combined variation is when you're doing a direct variation with an inverse. Combined variation is when you're doing both of these together. They're combined, okay? So the time a car travels can vary up or down, plus or minus, as the distance and rate of speed. So this was the distance that a car went. This is the time. Sorry about my focus there. This is the time that the car travels. So the less time you're in the car is because you traveled more distance and more speed. You're going to be in the car for more time if you go less distance and less speed. See? So that's how the relation is. Now, all the videos from 12.5a through this one, 12.7c, discuss variations. There's 7 videos in all. And if you're confused, you need to watch the previous 6 videos, okay? You walked into the middle of a movie and you don't know what's going on. So go back and watch the beginning of the movie. Our next video is 13.1a. That whole chapter is about quadratic equations. I'm going to talk about the standard form of a quadratic equation, all right? We'll even do a little graphing. All right, that winds up chapter 12. That is the end of us talking about the relations of functions, and I'll see you next video. Keep going. I'm proud of you. Bye.